Hello everyone, our group is Huawei 16 Pro Max. Our system is so-called Step is an e-commerce website development. In the phase 1 of project is build a simple system. So at first, open the VPC in AWS to create a VPC for this system. Choose the VPC and move. Name the VPC. Set IPv4 CIDR block to 10.0.0.016, not IPv6 CIDR block. Set number of availability zones to 1. Create customized subnet CIDR block in US each 1A to 10.0.0.024. Gateway set to 1 agent. VPC endpoint set to none. Then create VPC. After create VPC, go to the left navigation, choose subnet, create subnet. Create public subnet first. VPC ID, choose project VPC. Name the subnet, choose availability zone US H1B. IPv4 subnet CIDR block pro 10.0.2.024. Then create subnet. Create private subnet. Name the private subnet. IPv4 subnet CIDR block, enter 10.0.3.024. Then create subnet. Go to row tables. Select the publish, then create the subnet associations. Create the ED subnet association. After that, deselect the publish, select the private to make the subnet associations. Same with the publish. Then select project subnet private 1 and project subnet private 2. Then save associations. Now create a security group in VPC. Name the security group name with project web server. Write in the description with allows SSH, HTTP, HTTPS, and choose the VPCs with project VPCs. Then add rules for SSH, HTTP, and HTTPS. Then set the source to anyway-IPv4. Then click clear security group. Then open the EC2 in AWS. Create the launch instance in the dashboard. Then name the instance name. Click start, choose Amazon Linux and the Amazon machine. Select the Amazon Linux 2023. Instance type, select T2.micro in the KeyPad login. To create a new KeyPad, name the KeyPad type in RSA and set the private key file format in .pem. Then VPC, choose the project VPC. Subnet, select the project subnet publish 1 US each 1A. Change auto assign to enable. And did the select existing security group. In the common security group, choose the project web server. Then create launch instance. When success to run instance, then create connect for connect to instance to do configurations. Open Windows PowerShell with run as administrator for upload folder from Windows to Amazon Linux. Use the sudo yum update -y to update Amazon Linux system for instance latest version. Enter code sudo yum install httpd -y to install Amazon HTTP server. After install HTTPD, enter sudo system ctl start HTTPD to start HTTPD. Then enter the code sudo system ctl enable HTTP to enable Amazon HTTP server. After above action, use sudo system ctl restart HTTPD to restart Amazon HTTP server. Enter code sudo -r ec2 users.ec2 users varwww.html to set permission. Now need to upload the folder of this system. Use this command to upload the folder. Replace part for upload folder. That will pop up the confirm to continue connecting. Then enter yes to continue and wait for upload done. After upload folder from Windows, back to the Amazon Linux to enter cd www.html, go to HTML director. Unzip e-commerce.zip. Then need to move all file to the HTML director. Use this course to move it. Use this command to delete folder. After that, restart Amazon HTTP server. Need to install PHP to run the PHP files. Then need to install the database. After install MariaDB, let MariaDB start. Then set MariaDB to enable forward. And to check the MariaDB's status is active. Before create database and insert data to SQL, need to log in with root. Use this code to stop MariaDB first. To log in MariaDB without password with this code for bypass login into SQL. And enter code MySQL -u root into MySQL to change permission. After logging SQL, enter this to change the root user's password and ensure that the permission change take effect. After done these two steps, to exit the MySQL. After change permission, need to find and kill MySQL process. Use this code to check the PID. Enter the PID to kill the MySQL process. After that, restart the MariaDB to log in MySQL for create database. After logging MySQL, enter create database COMM to create database for this system. After done create database, enter use ecom for into the ecom database for create table and insert data into the database.
So good day sir, my name is Teacher Ni. So right now I'm going to demonstrate the phase 2, which is how we implementing the phase 1. So right now I'm going to remove the files inside the e-commerce folder to avoid conflicts with other files. And you can see that after removing the files, the website is look like this. Next, we will create a security group to allow our web server to access to our RDS database instances. So in this case, we add an inbound rules which is applied to IPv4 traffic and allows MySQL database connections. Then it will only allow traffic from web servers to connect to MySQL. For the outbound rules, we keep it as default. Next, we will create a database subnet group and use two private subnets for the database, which means our database is not publicly accessible over the internet. So after create these two things, we will configure a MySQL database instances and using the endpoint later on. Then we will set our EC2 instances to connect to the RDS database. So for the security group rules, we will configure to allow the inbound connection for both EC2 and RDS while the outbound traffic is fully open. So to connect our website to RDS database, we will using the endpoint that we just copied to replace inside our connection file. Then we also replace the credentials that we just created on database instance. After replacing the information, we will zip the inconfirms file. Then we will securely transfer the files from our local machines to our EC2 instance. So after successfully uploading the zip file, we will go to the web root directory and unzip it. So after remove the unused file, we will move all the files inside the e-commerce folder to web root directory. Then we can see that our website is become visible, but there is no any function yet. So to make our website has functionality, we will access to RDS MySQL database. So since there's no any tables in our database, then we will create tables and insert the value. So after create tables and insert the value, we can see that there's 6 tables in our database. So right now our website has functionality because we have created tables and insert the value in our database. So before we proceed to perform CRUD in our website, we must log in first. So in this case, if we add the item to cart, it will appear in our cart, and also for the backend, it will also add it to cart table. So right now, if we delete the item, it will remove from our cart in front end and also backend. Then, if we edit the quantity of item, it will reflect to the subtotal. And also for the backend, the quantity will be also changed. So that is all for the step on how we implementing the phase 1. Thank you.
Hi, my name is Tan Jiaqian, and we're going to present about phase 3. For the following, I will show all the first 3 steps. First step, we need to create the target group first. So we create the button create target group to fill in the information about the target group. We enter the target group name first. Project target. For the VPC, we select the project VPC. Health check part column, we enter index.html. After filling in all the information, we click the next button. It will show the state is running. We take this one project and create the include as pending below buttons, and it will show in the review targets. After this, click the button to create target group. It will show the successfully created the target group and the details of the configuration target group. For the next step, we need to create load balancer, so we create the create load balancer button first. We need to select the load balancer types. For our project, we use the application load balancer. Enter the load balancer name, project LP. VPC, we also choose the project VPC. For the availability zones, we tick these 2 availability zones and make sure this is the private subnet and this is the private. After this, security group, choose the project web server and TCC security group. And default action, click the project target. Next, we click the create load balancer button. It will show I successfully created the load balancer, and it will show the details of the load balancers I created just now. And I copy the DNS link and go to another page and try to load this link. The website cannot show. Next, we click the instances and tick this project. create agent, and create the create image. And we enter the image name, project config, and click the create image button. It will show the image successfully created for these instances. Next step, we need to create launch template. Create the create launch template to create new launch template. Enter the name, project template. For the my AI, click on by me. Next, we need to make sure AI is already selected project config we created just now. Instant type, we need to choose the T2 micro. Key pair name need to choose the TCC project. For the firewall security group, choose the select existing security group. For the security group, we select project web server and TCC security group. After filling all information about launch templates, we click the create button to create the launch templates. It will show I already successfully created the launch templates. Next, we try to run DNS link again. Go back to the root balancer, copy the link, and paste to the another page, and it will successfully to display the website. We can try to run the website. We go to the category, add item, select the item, and add to cart, and we add another item. Also select the item and add to cart. Next, go to the shopping cart, and it will show the item we add just now, and try delete item and all item. So the website already can function. So that's all for the first 3. Thank you.
Hello everyone, my name is Joker Singh. Today I am going to share with you the step of implement auto-scaling for AWS EC2, which allows us to automatically increase or decrease the number of EC2 instances based on the ultra demand, terabyte increasing, system availability, and the controlling cost. Now the first step is EC2. Since EC2 has been done in phase 3, we can check here that our EC2 has been complete. If it is not complete, please go to the phase 3 to watch the step process. Next, we can go to auto-scaling group to create a new auto-scaling group. The core of this step is selecting a step-tube template, it entering a template name and selecting a default version. For example, I key the name is TCC project. In launch template, I choose about the project template for the EC2, and we can see about the version is for the default, and can see the description and information for the launch template. We can see about the instance type, MIID, security group ID, or more. Next step is choose instance launch option. This step where we need to select a operate instance type and then set up the network VPC available zone and subnet. Typical, we choose multiple available zone for the better the load distribution for the priorities the use of public subnet for greater visibility in external access. Next, we want to go to step 3. Step 3 is integrate with other service. This step is focused on deciding whether or not to use load balancing, and if we choose to attach to an existing load balancing, we can specify a target group such as HTTP server. The next, we want to skip about the VPC lattice and the application recovery controller. For the next, we also can to add the healthy checking. We go to enable the LT checking so that the system can be automatically detect and replace the instance. Next step, we need to set the scalability policy, which is critical. While define a minimum number for instance is 2 and a maximum number of instances up to the 6. For automatic scaling, we will use a target tracking policy. For example, when the CPU utilization reaches the 16%, the system will be automatically increase the number of instances. In addition, we can set a warm time for the instance, for example, 3000 seconds, so that the new instance have enough time to prepare before they. The next step is relatively simple. We can choose whether to add notification so that we can be alert when the instance is scaled up or down. And the next step is also for the add the label to make it easily category and the identify when the management multiple auto scaling group. You also can choose you want to add or not. Finally, we move on to the audit first. In this section, we need to double check all the previous settings to make sure that each configuration item is as expected. If everything is correct, click the create button to successfully create the auto scaling group. If the page does refresh automatically, we can manually click refresh to check the status of auto scaling group creation. This brings me we are success. With AWS EC2 auto-scaling, we need flexible scale resource, optimize cost, and improve the high available of application so that the system can be better cope with different load conditions and ensure continuous business.